Hi everyone, today I'm going to take a topic from kinematics first PU, and that is how to draw displacement time graph, velocity time graph, distance time graph and speed time graph for a body which is thrown vertically up. Now when you throw a ball up, its initial velocity is upward but acceleration due to gravity is downward, and whenever initial velocity and acceleration are in opposite direction, the speed of the body will decrease. So the body will move slower. Then at some point its velocity will come to zero as I've shown you here. And then while coming back, its velocity and acceleration due to gravity are in same direction now while coming back. So now the body will move faster and faster but in opposite direction to the initial direction. So here what I will do, upward direction I will choose positive. Okay. Now, if you see in this example, here the body is given 10 meter per second, and as it goes up, its velocity decreases in magnitude, and while coming back, its velocity increases in magnitude. But in this part, velocity is positive, in this part, velocity is negative. And acceleration due to gravity is downwards, so it will be negative, which is constant 9.8 meters per second square. So let's first draw velocity time graph. At time 0, the starting, what was the velocity? 10. So the body starts with some positive velocity, 10 meter per second. Right? So let's say the unit is meter per second. Now as time increases, the velocity will decrease in magnitude. Right? Now will it decrease in a straight line or curved line? How to remember? Well, slope of VT graph is acceleration, and here acceleration is negative constant, and negative constant means how will your graph be? Like this. So it will continue like this, and then this is the velocity time graph. So if you look carefully, let's see whether it matches with the situation or not. At time 0, 10, and as time increases, as you wait, what is happening? The value of the velocity is decreasing, so the number is decreasing. 10, 8, 7, then finally 2, then 0. Right? So somewhere here velocity became 0. At this time, velocity became 0. And from that time, as you keep waiting, again the velocity is increasing but negative values. So minus 2, minus 5, minus 8. Finally, again it will become minus 10. So this is the point where you finally catch the ball back, right? What about speed time graph? Let's see speed time graph. Remember, this time corresponds to this moment. Now, you know that velocity, if you take magnitude, you will get speed. For this part, your velocity is positive and speed is magnitude of velocity. So if you take magnitude of all these positive number, same number you will get. So the graph will be exactly same like here. Right? What about thereafter? Here velocity is negative, but speed cannot be negative because speed is modulus of velocity. So when you take modulus of this number, again you will get plus. So the graph will be like this. So remember, the graph cannot be negative if you draw speed time graph. So this is velocity time graph. This is your speed time graph. Now let us see how will the displacement time graph look like. Obviously, we are measuring the displacement from this initial position. Okay. So let's see how the graph will look. Remember, as the body goes up, your displacement is upward and it is increasing. And when the body comes down, displacement is from initial to final. So still it is upward, but your displacement is decreasing. Okay. So when the body is here, this is your displacement. When the body is here, this is your displacement. So it is increasing. While coming back, this is your displacement initial to final. And when it is here, this is your displacement initial to final. Okay, so this is your displacement. I hope you understood. So displacement remains positive, but for first part it increases, second part displacement decreases. So how will your graph look? So let us say this is the time which corresponds to this time. Okay. Now What is slope of displacement time graph? Slope of displacement time graph is velocity. And what happens to velocity while going up in magnitude? It decreases or increases. As it goes up, the velocity is decreasing. So the slope should decrease in the first part. In the first part, your slope should decrease. But remember, it should be positive. The slope should be positive, right? How will you draw graph with decreasing slope? This way, right? So it should start with very high slope and then it should go to low slope. So it starts with high slope and then low slope. After you reach this point, what will happen? After this is up to this point, okay? So this is for first half. For second half, what will be your slope? Again velocity. But while coming down, your slope is, remember, increasing. And it is negative. Here it was positive but decreasing, right? It was positive but decreasing. Now it is negative velocity. So increasing slope, how will you draw? From horizontal to vertical. So from horizontal to vertical. So this is how. So if you look carefully at this point, if you draw a tangent, right, it will be acute angle, right? So here slope is positive. Here slope is positive. But in this part, if you draw tangent, your slope will be negative, right? Now let us see how to plot distance time graph. Please understand one thing. Here when I write distance, it means path length. Now, path length cannot decrease like displacement. In this example, let's say this is 10 meter and this is 10 meter. While calculating displacement, you measure from initial to final. So that is increasing and then again it is decreasing. And when the body comes back to the same point, displacement becomes 0. But distance is 10 meter, again here 10 meter. So total path length is 20 meter. So distance cannot decrease like here. So distance will follow similar graph like displacement while going up, because the speed is still decreasing. So slope of distance time graph is still decreasing. So slope should decrease. But from here to here, your slope should increase, no doubt. Slope should increase because it is moving faster. So the velocity magnitude is increasing, no doubt. So how will you draw a graph whose slope is increasing? Increasing slope means what? From horizontal to vertical, like this, horizontal to vertical. But you cannot decrease. Then how will you draw the graph? Well, you have to go this way. Yes or no? From horizontal to vertical, but you should not come down. So this is your distance time graph. Give importance to these students because many students do mistake while plotting distance time graph. So remember, the slope of distance time graph is also velocity in magnitude, but distance, unlike displacement, cannot decrease.